next speaker is Yuju, and he will talk about the new principle of smart energy from ecosystem perspective.
Good morning. Yeah. So my talk is a new principle of smart energy from ecosystem perspective. So basically, okay, I'm not sure why the format has been changed a little bit. Okay, so first I'm going to talk about from the trend of smart energy system, the roadmap. So traditionally, I mean, we have to go through from centralized architecture to a smart grid or intelligent architecture. Now we're moving into this decentralized architectures. Yeah. So the customer needs have a diverse, from diverse perspective, they have different requirements. So also the energy generation and the storage technology have a diverse feature. Yeah. So based on that, we are actually driving towards the direction we want to be able to, in the future, we can optimize the distributed energy system. Finally, we can move into a decarbonized stage. Yeah. So for the last two stages, we consider is moving from disruptive to evolutionary to revolutionary. Yeah. So this is actually a summary from in China. They actually, Accenture company actually predict there's a large market value for the smart energy system. Yeah. So you can see from here, the definition of a smart energy system is quite diverse. They have a different perspective. Yeah. So far in China, they have built like around like 88 projects about the smart energy system, but very, very few of them has been successfully economically or at the whole system level. The reason is because the system feature is quite diverse. It's hard to manage and also cross different discipline and different industry. So this actually create a need to investigate a fundamental principle, how we can integrate a diverse technology or assets together to deliver a comprehensive solution for customer. Yeah. So in order to understand why this diverse thing can cause trouble or bring benefits, we want to talk about two sides of diversity. Bad side is, I mean, it creates chaos. So which means we use a battery system can show as one example. So if the battery has keep cycling for many, many times, the behavior actually drives the imbalance between the batteries. So this behavior actually can create a very bad unbalance, which let the system, the whole system actually lose the function. Yeah. So in order to describe this diversity, we can introduce a concept as a similar as entropy to quantify how this diversity behave. And also we can use an exergy to show what's the available energy left from the system. Yeah. Also, this diversity can be driven from cross-coupling between the energy network. So this will create a profile diversity for multi-energy network. And also from an infrastructure perspective, I mean, the eco-behavior of the smart energy system can create an application diversity, which means the customer have a different diversified reason. Yeah. And also this is also driven by the application multi-value. Yeah. So based on this, what we want to do is, I mean, we can actually, from energy flow perspective, the system can create a entropy flow and also create an exergy flow, which is equivalent as a cost and also the return. Most importantly, I mean, if we can introduce the energy to matter flow, we actually create one more dimension added into the existing energy and information-based smart energy system. Yeah. So now we talk about, based on this diversity, where we can find for the fundamental principle. Yeah. First, we can see if we can use battery as one example. If we can, we do this charging rate with a very low rate, system will be more balanced. If we do the charging rate with much higher rate, system will have much unbalanced stage. This will actually cause a low entropy and high entropy state. Yeah. So this both state, it shows it will have a much less exergy. So which means there's a relationship between the exergy of the system related to the entropy of the system. Yeah. So maximum exergy actually in the middle somewhere, not in the range of the low entropy and also not in the range of the high entropy. Yeah. So based on this, we try to write one principle. Yeah. So for distributed energy system, yeah, the decentralization itself actually compared to the one piece of energy system, it creates entropy increasing already by this dispersing the structure. Yeah. So it's very obvious in the battery system. We try to manage a large battery system with many small battery. So this shows the IoT methodology can only reduce the entropy increasing from dispersed structure. Yeah. So based on this, what we find out is, the structure dispersion is actually the key reason for most interconnection-related system degradation. Yeah. So by using IoT method, what we can only do is bring this, reduce this entropy to make the interconnection of the diverse system can work as one piece. But not necessarily you can contribute to exergy. Yeah. Now we move to this diversity actually can bring the multi-value for the system, which is can create the exergy. Same thing, use the battery as one example. If the unbalance happened between batteries, if we can do the active balancing or we call it repairing, we actually can bring the more exergy out of the system. So which this shows us energy and matter flow is the mandatory driver for maximum the system exergy. Yeah. So based on this, we think we can introduce a system exergy, which means by bring the energy and matter flow between the interaction of the system, we can let the system have more exergy when the system getting more diverse. So based on this, entropy minimization and exergy maximization rule, we can actually introduce a variable to define as a capability of convert entropy to exergy as an equal intelligence. So based on this, we can actually move a traditional information flow-driven smart energy system into a matter flow-driven information and smart energy system. So from here, we can actually see the most IoT methodology, we can only bring the system entropy as low as possible. But in order to maximum system exergy, we need to use this energy and matter flow. Yeah. So now I'm going to show one example we're using to apply these rules. This is actually a smart city application. What we are trying to do here is, we're trying to mimic a smart city energy system as a nature ecosystem. So in the smart city, the building, we actually can treat building as a stationary terminal, similar like a plant. We can treat this vehicle system as a mobile energy terminal, similar like the animal. Yeah. So the coupling mechanism between these two, which can be built similar like from involving mechanism, which we can define this, from here. We introduced a mechanism called a solo storage charging hydrogen terminal. Yeah, so this one actually we can use a BIPV-based solo to deliver energy to the zero carbon transportation network. Yeah. So based on this, we actually introduced some fundamental routine service to coupling building energy network with a vehicle energy network. But since the system is quite diverse, so there's a complexity between the interactions. So we want to introduce another mechanism so we can actually interact the building network with the vehicle network through an ecosystem based on this eco-intelligence with equation can show derived QoS based on the fundamental one. So the derived QoS is based on self-learning, optimization based on local, and eco-intelligence is actually involved globally with a better economy return for sustainability. So this actually shows by introducing these eco-intelligence variables, we can actually link directly to the resource utilization rate of the system by bringing the utilization rate to much higher rate than traditional way, and let the system go into an evolving structure and derive its own. So by introducing one, we hope we can introduce this methodology into a large, bigger carbon neutral smart energy ecosystem. Yeah. So the conclusion is based on diversity feature of the smart energy system, we introduced a fundamental principle based on eco-entropy and eco-exergy. Yeah. And also we introduced the eco-intelligence index based on the conversion capability of eco-entropy to eco-exergy. And we showed one example for smart energy ecosystem for smart city. Yeah. Thank you. Sorry,
time for a couple of questions. Can you discuss the next steps of this work?
Yeah, this one right now we're working on this smart city. So we're actually on the energy node. We try to create a coupling between the BIPV with charging network with hydrogen local generation. So the benefits is, I mean, we don't have the issue to build the whole hydrogen infrastructure. Yeah, and for smart city, the I think 70% energy came from building and transportation, right? So actually, we're using the edge nodes coupling for these two stationary and mobile terminals. So in that way, we actually can derive a bottom-up methodology. Yeah. So hopefully we can using the machine learning, big data stuff, and can solve this issue. I mean, from the end. Yeah. Thank you.
Do you think that's your methodology will also be compatible when you consider singularities like a disaster event?
Yeah. So right now, because I mean we're developing using the new tools from machine learning, right? So the system that we designed the rule, but algorithm actually derived by itself. So now we think the system will have more adaptability, and for the future in different scenarios, yeah, including the one you mentioned, yeah. Okay.
Yeah, let's thank you.
Thank you.